Viewers, my name is Adiko Oluwaseun from Kwara State University, Malete, world-class university. I'm about to demonstrate linear programming under microeconomics. Under linear programming, we have two methods of solving linear programming. The first one, we have the graphical method. While the second, we have the simplest method. Now, I'll start my linear programming with the use of graphical method. So let's see. We're going to start with the use of graphical method. Now, we should note one thing, that in microeconomics, is either we minimize our cost or we maximize our profit. So I'm going to start with an example of maximization. An example of maximization. Example. Let's say we have profit equals 5x1 plus 3x2 with a constraint of 6x1 plus 2x2 less than or equals 36. 5x1 plus 5x2 less than or equals 40. We have 2x1 plus 4x2 less than or equals 28. Now, the objective function is given to us as 5x1 plus 3x2. Now, this is what we are told to maximize. But before we start maximizing under graphical method, we go to the constraint. Now, going to the constraint, we pick the constraint one after the other and equate them to the constant. Solution. Now, the first one, we have 6x1 plus 2x2 equals 36. Then we have 5x1 plus 5x2 equals 40. 2x1 plus 4x2 equals 28. Now you can call this constraint A, constraint B, and constraint C. Now note one thing under graphical method. We always make use of the non-negativity conditions. Now the non-negativity condition is saying that when x is greater than or less than 0, or when x is less than or equals to 0, that is saying that the non-negativity is just saying when x is less than or equals 0, or y less than or equals 0. That's the non-negativity condition. Now, I'm going to start with my objective function. Now, the first thing you need to note under graphical method is you pick your objective function, because we note that if you are solving inequalities, let's say we have two objective functions. Now, if you are solving greater than, we try to look at this point and shade like this, that it is greater than. But if you are solving less than, that is less than, then we'll try and shade it within. Now, the same thing, and note that you'll be having x2 here and you're having x1. Now, I'm going to use the same thing. That means if I'm having x2 here, my slope must start from this side. That is, my slope must start from the x2. So definitely, I can come to the objective function and make x2 the subject of the formula. So I'm going to come to the objective function. I have profit equals 5x1 plus 3x2. Now, making this subject of the formula, I'm going to have 3x2 equals profit minus 5x1. Then I'm making x2 subject of the formula, so I divide everything by 3. So therefore, here I will be having x2 equals profit over 3, then minus 5 over 3 x1. Now, this is our objective function. These are objective functions. Now from this side now, we cannot go to our constraint and do the same thing. But what we need here, we now make x2 subject of the formula from the constraint and look at the slope. Don't forget, from this objective function, this is the slope of x2 here from the objective function. Now we'll come to this place and look at the slope that is closer to this one of the objective function and make it a simultaneous equation and so. Now from this, let's pick the first one. The first one is saying we have 6x1 plus 2x2 equals 36. Now I want to make x2 subject of the formula. Then I'll be having 2x2 equals 36 minus 6x1. So I divide all through by 2. All through by 2. So I'll be having x2 equals 18 minus 3x1. Now if you look at this is from the slope, the objective function or the constraint of a. And if you look at the slope here is 3. Now after doing this, then the next, because we are making use of graphical method and we said we are making use of the non-negativity condition. Now the first thing you need to do, now say when x1 equals 0, then therefore x2, if this is 0, so your x2 will equal 18. Then you say when x2 equals 0, then x1, if this is 0, then x1 will equal 6. That is, you make x1 subject of the formula. So from this point now, we now have our x1 to be 6 and our x2 to be 18. Then you go to the second objective function. We have 5x1 plus 5x2 equals 40 from the second objective function. Now looking at it here from this perspective, we still make use of x2 subject of the formula. We do the same thing. Now if we do the same thing to here, we have 5x2 equals 40 minus 5x1. Divide all through by 5. So you'll be having x2 equals 8 minus x1. Now if you look at this, the slope of this one here is what? Is 1. So this is coming from the second constraint, which is constraint B. Then you do the same thing to when x1 equals 0, then x2 will equals 8. When x2 equals 0, x1 will equals 8. So you're having 8. Then you go to the third constraint. The third constraint is telling us that we have 2x1 plus 4x2 equals 28. Make x2 subject of the formula. You'll be having 4x2 equals 28 minus 2x1. Divide all through by 4. So you'll be having x2 equals 28 divided by 4. When you divide 28 by 4, what do you have? You'll be having what? You'll be having 7 minus 1 over 2 x1. So this is coming from the constraint C. It's coming from the constraint C. Then you can now come here and continue to finish your workings by saying when x1 equals 0. So when x1 equals 0, what will be our x2? The x2 will equal 7. So when x2 equals 0, if this is 0, then what do you have? If this is 0, where is it? x2. So if this is 0, you have 28 divided by 2, you have 14. So x1 equals 14. So we have 14 and 7. Now, then this is coming from constraint C. So we have the constraint A, B, C. Now don't forget, this is our objective function. Now looking at our objective function, we are having 5 over 3. And if you do 5 over 3, you'll be having 1.6666 like that. So that means we have to look at the slope that is closer, the two slopes from this constraint that is closer to this. Do you understand? But the first thing you have to do before you start solving, since you are making use of graphical method, so you plot your graph. You have something like this. So you're having x2 and you're having x1. Now from the constraint A, you're having 6, 18. So here you're having 18. Let's say you're having 6. You plot it down. Then you call this constraint A. You go to the second one. The second one we're having 8. So let's say we're having 8. So you're having 8 here. You're having 8. You trace it down. You call it constraint B. And go to the last one. You pick the last one. The last one is 14 and 7. So we're having 7. This is x2. The x1 is at 14. Let's see, we have 14 down here like this. So it chases down like this. So you have, this is constraint. You have a constraint C. Now looking at it now, we have to now shade. These are the feasible region. That is, this is where our solution lies. Then this is the point of the origin, 0. Now after plotting the graph like this, then you now go back to the constraint. Now looking at the first constraint here, this is constraint A. The slope of constraint A is 3. The slope of this is 5/3, which is 1.67. Now you come down to constraint B. Constraint B, the slope is 1. Now if you look at 1 is closer to this, right? This is 1. 1 is closer to this, but this is, the first one is 3. 3 is very far away from this. Then you go to the last one. The last one is half. 1/2. If you look at it, 1/2. So we're having 3 slope. 3, 1, 1/2. So if you look at the one that is very, very close to 1.67, you can see that we have 3 and 1. 1/2 is far away from 1.67. So definitely the two slopes that we are going to be making use of is slope A and slope B, because 1 is closer to 1.67 and at the same time 3 is closer to 8. But looking at 1/2 is very far from what? 1.67. So definitely the two solution is constraint A and constraint B. So we write it out by saying we have our x2 equals 18 minus 3x1. Then you have x2 equals 8 minus x1. So this is from constraint A and from constraint B. Now the next thing, just turn it to simultaneous equation. Bring the two variables together and make the constant stand alone. So in this case, you bring the constant to the variable to make the second variable. So we have 3x1 plus x2 equals 18. Then you have x1 plus x2 equals 8. So you can use elimination method by eliminating x2 because we are having a coefficient of 1 here. So this minus this, we are having 2x1. This is 0. This is out. So here we are having 10. So therefore, you divide 2 by 2. So x1 equals 5. Now our x1 here is giving us 5. So from this side, we can just say substitute x1 into any of the equation. Let's pick equation A. Into equation A. Equation A, x2 equals 18 minus 3x1. So we substitute x1 now, which is 5, into this. So we have x2 equals 18 minus 3 times 5. So we have x2, 18 minus 15. So x2 equals 3. So from this point, we have x1 equals 5 and x2 equals 3. Now, this is our solution. We've gotten the x1 and x2. Now our x1 is 5 and our x2 is 3. Now from this point, we can now insert this to get our profit. Now this is the output we have to produce. X1, we have the unit of x1 we have to produce, and the unit of x2 we have to produce to maximize our profit. So you go back to your profit function. The profit function given to us from the question is we have 5x1 plus 3x2. So just substitute. So you can say therefore this is 5. X1 is 5 plus 3. X2 is 3. So we are having 25 plus 9. So therefore profit equals 34. So that is just the final answer using the graphical method. Now we can at the same time do simplest method and we arrive at the same answer. Do you understand? Alright. Now this is just the use of graphical method to solve linear programming under maximization. And what we've just done now, we just maximize profit of a firm. Let's assume that this is a firm in Kwara State University. So what we just did here is we just try to maximize the profit, giving us the profit objective, the profit function, 5x1 plus 3x2. Then we have the constraint. So the first thing you have to do, you just have to bring out the constraint, identify them as ABC. Then you know we are making use of non-negativity condition. When x is less than or equals 0, y is less than or equals 0, then you solve further. You plot your graph, then you end up having your x1 and x2. Then you insert them into your objective function. Then you get the total profit, which is 34. So thank you.